are recording. Oh, I see. There's the flashy button in this new version up in the top. So, well, welcome everybody. Thanks for taking time out of your schedule. And oh, holy cow, Lindsay, are you really on? Please talk. Please talk. That's so cool. She talks. Oh, she's chatted. Yes, that's just. We always assumed that Zoom didn't work in the air because you can't watch streaming video like Netflix or YouTube. But evidently, we can now video conference from the airplanes. Hot dog. Hot dog. I'm way stoked right now. That was worth the price of admission right there. She's not going to push it with a video. What? You don't want to show us your airplane self? Come on now. All squished between everybody. Well, welcome to our August meeting. Thank you so much for joining us today. And we have some good and exciting work to start together as we head into the school year. And many of you are already heading in. And we also have a special treat to kind of help initiate that work. And that is Rob Barnes is joining us from the Van Allen mission. Dawn, do you want to introduce our guest?
Sure. I'm really excited. Thank you so much for coming tonight, Rob. Mr. Rob Barnes is a software engineer working on NASA heliophysics missions at APL, including the Van Allen probes. Tonight, Rob's going to be guiding us through the new and improved Van Allen probes data access gateway, which he designed and created. The new design and capabilities allow the public as well as scientists to access the real-time data with greater ease than ever. Thank you so much, Rob. I'm going to turn it over to you now.
Okay, thank you very much, Dawn. Lovely to be here. I'm going to try and share my screen and see if that works, because it won't be much point unless you can see what I'm seeing. Let's see. Okay, did that work? Can people see my screen?
Yes.
Yes.
We can.
Okay, good. So like Dawn said, I work on Van Allen Probes mission. First off, do you guys familiar with that mission or not?
We certainly are.
Okay, excellent. Wonderful.
Dan Smith and Dan Baker gave a talk, or maybe several talks, I don't remember now, about an overview of the mission maybe a year or more ago, and then they showed us how to access the data on the old system that I was talking with you about today.
Okay, all right, excellent, wonderful. So my part of the mission was actually to come up with the Science Gateway, and this is the site we're going to show you this evening. A big part of the mission for me was trying to get the data out, not just to the scientists who are actually using it, but to people who paid for it, the general public, anyone who's interested, educators, teachers, students, so that they could actually work with real data from a real mission. So hopefully you can see here, starting off at the Van Allen Probes homepage, there's a link right in the middle there called Gateway, and that will take you straight to the gateway. So let's click on that. Okay, can everyone see this? You should see the Gateway website, and in the middle of the page here, we've got this movie running. Can you see the movie running?
Yes, we sure can. That's pretty cool.
Excellent. Okay, so what this is showing here is actually one of the things that we do on Van Allen Probes, you may have heard about it, is we have a space weather broadcast that comes on off the spacecraft, the two spacecraft, when we're not actually downlinking or commanding. So we have a couple of institutions that we partnered with internationally who actually download this data. They listen to the spacecraft when we can't, and then that data gets fed into APL. And that's what you're seeing at the top of the plot here. You're seeing actually as the little grey dots go around, that is the last 48 hours worth of data that we observe. So the plot on the top left there is looking down from the North Pole on the Earth. You can see the Earth rotating beneath it. And there you can see the elliptical shape of the orbits. The other two on the other side are looking from the side, and then the other one is looking from behind the Earth. Underneath this, we have what we call a context plot. This first one, this little white wiggly line here, is actually a thing called the DST index. And when it dips, you see these dips about midway through the plot. That's when a geomagnetic storm has gone off. And then you'll see the recovery phase after that as it comes back up. So this shows about a year's worth of data, and you can see it's been fairly quiet. We've had, maybe 4 or 5 smallish storms, and then 2 fairly big ones. At the bottom here is similar context plot. This is actually using real data, space weather data from Van Allen probes, and what we're plotting here is particle flux, is the color, and time along the bottom axis there, and then vertically it's L shell, You guys familiar with what an L shell is?
It's always good to be reminded that some of our audience members are not with us in person tonight, but they'll be watching the video later. So if you could recap that for us, Dr. Barnes, that would be wonderful. Also, if you can embiggen, I know that word is incorrect, but I love it. Embiggen that window, if you can maximize it, we can see your, yeah, perfect.
Okay, let's try that.
And then we can see that. But yes, if you would explain an L shell to us again for those who might be joining us later, that'd be wonderful.
Okay, well, an L shell is basically it's a measurement that you calculate by tracing a field line, a magnetic field line from the surface of the Earth out until it hits the magnetic equator. And then there's a formula that then relates that measurement to an L shell. So close into the Earth, the equator, you have very low L's, and as you go further out, they map much more towards the poles, and you get higher L's. So it's a convenient way of plotting data that you know is organized by magnetic field. So if you plot as a function of L here, you can see at the bottom here, that little line at the bottom brightening is the inner radiation belt, and then above it you'll see the outer belt, which kind of comes up and disappears. And where we had that big storm in the middle of last year, you can see that reddening, brightening in the middle there, where particles were suddenly injected into the radiation belts and the fluxes all spiked up, and you were seeing the effect of that storm. Okay, so moving on. At the top of the page here, we have various buttons that link to various parts of the site that you can play with. Clicking on, let's look at this. This is the orbit plotter. This is a nice little tool where you can come in and you have at the top here, you can pick a time, so you can pick any time you want. And it will show you where the spacecraft currently is at that time. And you can change the length of the track and various things, and you can switch to different coordinate systems. This one is a GSE coordinate system. So this actually has the rotation of the Earth taken out of it. So you can see the elliptical shape of the orbit. If you plot in a kind of geocentric coordinate system, then you get this weird and wonderful pattern, because this is from the Earth's perspective now. So the spacecraft, although they're orbiting independently of the Earth, you're seeing the effect of the Earth's rotation added into that. So this tool, you can play around with this and explore with that. So that's the first thing that I think was covered in the worksheet that Dawn was working on. If we go back to the home page, let's take a quick look here at the space weather data we have. So this is something that is updated all the time when we're out of regular contact. And you can see here these wavy little traces. They're not particularly interesting at this time, but this is actually what we get as raw data and process it here at APL. And you can scroll down here, and here you can see this is some of the, at the bottom here, some of the particle data that we get. Now, the space weather stuff is a limited subset of the full mission data. We don't have a lot of capacity to broadcast stuff outside our regular downloads. We've got other things we should be doing. So it's a kind of minuscule look at what we currently see. Going back to the homepage again, here's the important one. This is where you can actually look at summary data from the mission. And again, up here at the top here, you have a little time button here, and you can advance this in time. So you can see here as we progress. And again, we have these geomagnetic indices at the top. And then you can change how much data you can actually plot. All these tools, open access, anyone can come in and play with it. One of the things that you can do is you can actually come in here, and there's this button up here where you hit change parameters. And this here gives you a list of everything that you can possibly plot. And then you can add to the plots by just clicking on this add button. And then you have various things that we can add in here. So let's go and add some data from Banner probes. We'll add some rep data. We'll add the spectrogram in here. And we click OK. And then at the bottom of the plot, there's our spectrogram appeared. And you can do cool things like you can come in here and let's move that panel up. So it's at the top so we can see it. Okay. Okay. And then you can come in here and hit edit here, and then you can come in and you can change the color bar on the plot. You can change the scalings, and various things like that. Now, the other fun thing that you can do is there are buttons at the top of the plot here where if you click on one of these, you can get a PDF of what you're currently looking at, or a PNG of what you're currently looking at. Or if you wanted to share a plot with someone or collaborate with someone, if you click on this Get URL button, it opens a thing here, and then you can either cut and paste this link into an email. And if you send that to someone, they will see exactly what you're seeing on your screen. Or you can use this little URL code here that you can print out and put on a poster or put in a paper or whatever. So like I said, this is open to anybody who wants to use it. There's all sorts of other things on here. We have things like a bibliography. This lists all the publications that come out of the Van Allen Probe's mission, which is actually a useful thing to have. What else do we have? We have L-shell context plots like you have on the front page there. So this again is showing, it's like a still frame from the movie, but here you're actually seeing this is the space weather data here, and you can see how spotty it is, and then beneath it, that is the actual science quality data that's coming out from the mission. And here you're putting about 30 days of data, and you can step through and you can see how the radiation belts evolve over time. Okay, I think that as a demo is pretty much that. Anyone got any questions?
I just had one comment, Rob. This is Dawn. Could you show them where the instruction link is?
Yes. Playing with these things, right at the top here, there is a link here that gives you instructions on how to drive the thing and operate it.
And how did you get there from the very front page?
Just click on any page that has got a plot on it. So if you're on the home page, go to either Space Weather, there's the link there, or if you go to L-shell plots or summary plots, the link's right at the top there. So any page that's got one of these plots on, you click on it and you can interact with it.
Great, thank you.
Say, Rob?
Yes.
Could you go back and give me, a lesson in an L-shell?
I can.
I'm missing something there.
All right. Well, let's go to our old friend Google, and if you L-shell for Google, it will then list the definition of it here. Basically, what you're doing is you're tracing along the field line. So let's look at the image here. So this is the typical view of the Earth's dipole field, and you can see the field lines coming out along here, and you trace them out down to the magnetic equator of the Earth. And so the further out you get, the higher the L-shell, and it traces back to higher and higher on the globe. And the exact formula for it is this little thing down here, which is, where are we? R equals L cos squared lambda, where you're tracing geomagnetic latitude to a point where R is the radial distance. Okay?
So on the other diagram that you just showed, Rob, the lines that you showed, that would be like the 1.5 would be an L-shell, the 2 would be an L-shell.
Yes.
Okay.
So if you think about how RBSP is orbiting basically around the magnetic equator here. So the L-shell basically translates into effectively almost the radial distance of the Earth.
How is this different than a magnetometer from the ground or from like Artemis that's also sitting there watching the magnetic field as it moves?
Can you repeat the question?
How is this observation different than whether it's an Earth-based magnetometer or Artemis that is also measuring the movement of the Earth's magnetic field?
Well, ground-based magnetometers actually, they sit in the Earth's main field, which is what you're looking at here. And then when they're very sensitive instruments, what usually happens is you actually subtract off this main field, and the ground magnetometers are then looking at the residual induced field that's coming from the interplanetary IMF. And so it gives you an indication of what's happening above the Earth. They're not really measuring the Earth's field.
So there should be some relationship between this L shell and what a magnetometer reads from the Earth, should it not? You would see something appear on an L shell begins to show a difference.
Yes, if you have a measurement, say on this L shell of 4, okay, you have some event that happens, some particle flux or some current or structure that occurs there, that will then map down to the poles of the Earth. So on a magnetometer at the poles, you would see the effect of that change. Yes.
Okay, that helps. Thank you.
And funny you should mention ground magnetometers. I can do another bit of plug work here. One of the other things that we do at APL is we have a program called SuperMag. I'm going to put the URL in there. And that is exactly that. This is a network of, in fact, it's pretty much all of the ground magnetometers in the world. And in this, you can go in here and you can actually look at polar plots. We came up with a system of actually taking the ground magnetometers and putting little arrows to show you where the magnetic field is wiggling around. So if you're interested in that kind of stuff, please check out the SuperMag website as well.
Rob, would you be willing to put that in the chat box, the URL for that, or if somebody else knows that would be great so that we can capture that.
Sure.
Because I know that there are many in this group that would actually be very interested in that, since some of them actually have magnetometers at their school. So that would be a lot of fun for them to, a lot of fun.
Well,
serious science.
Yeah, well, one of the things that we do with SuperMag is we have the ability to actually create movies of this stuff. So you can actually view, let's see if we've got a movie in here that's actually going to work for
So like Helio Viewer for magnetometer data, is that what I hear you saying?
Pretty much. I mean, hopefully you can see this now. This is a movie of observations from January in 2006, and you can just see here the little wiggles of the magnetometers on the ground. It's not a particularly interesting day, but yeah. So there's a lot of good resources on that side as well. Okay, let me see if I can.
Is there anything else you want to tell us about that site? That seems pretty amazing.
Well, it's a thing that we've been working on for about 5 or 6 years. And these magnetometers, there are hundreds and hundreds of stations throughout the world. They're all administered by different countries, different institutions. They all have their own different way of handling the data. And it becomes a complete nightmare in how you work with this. But fortunately, the PI who works here at APL, Jesper Gerloff, he basically went around to all these different people and said, please, can I have your data? I'm going to clean it up. I'm going to put it together in a consistent form. And that's how we put together this SuperMag site. But basically, yeah, you can come in here and we have, similar to the Van Allen Probes Gateway, you have the ability to come in and you can plot the data, you can look at it. Let's see. So let's go and pick a region here where there's some magnetometers and just hit plot. Let's see. Let's do 12 hours. No, it's not going to work for me now. I broke it. Oh well. But basically, you can come in and you can plot all this data as either line plots or these polar plots that you were seeing. And like I say, we have movies and we have indices, so you can look at see where there's storm events occurring and things like that. But I will send you the URL. I'll put it in the chat. Okay, there we go. There's a plot. All right, so I'm going to unshare my screen. And let's see.
Lynn, you're going to have to watch the video later because I think you will. I think all of you Geons folks for sure. That's going to be pretty.
I know. I've been trying to follow. He did say that it shows a 30-day plot when you ask for it, and I guess you can specify which date you want.
Yes.
And then when I want a date, like there was one St. Patrick's Day, there was a big event, and then there was another one on June 22nd. When I request a date for the RVSP, do I want to pick sandwich the date that do I want to sandwich the date that I want, or do I want, how do I want to do it? Like the June 22nd. event, what date would I put in there? Because it's not going to interact with the Earth for 2 to 3 days, right? So do I want to see what it is beforehand and after with the 30 days? What's the best way for us to have the students select for that?
The best way is, I'm not sure if you can see, you've been able to see the screen or not, but the best way with the SuperMag stuff is if you're looking at the polar plots, you can actually navigate, and it shows you 6 of these polar plots spaced every 10 minutes or so. So you see the quiet time conditions, and then as you move through the time when the storm occurs, you'll see the sudden spin up and the vectors will get much bigger. So, I mean, it's really an interactive thing. You can set the students down there and they can just click through and survey, days worth of data in a few minutes.
Oh, well, that's really good.
Rob, would you have a minute to share your screen and maybe put in one of the dates that Lynn was asking about and walk us through how they would do that for the people that will be watching later?
Okay, I should be sharing my screen. Okay, here we are on SuperMag again. Now, one thing that I have to tell you about SuperMag is there is a delay in us getting the data. We don't get it. We basically have to reprocess it when we get it. So we do not have anything from 2015. Let's see if we can find something from last year. Okay.
Would you recommend that they use SuperMag or the Van Allen data gateway, the Access?
Both. I mean, they're two different projects. Basically, with Van Allen, you're getting the 4 or 5 instruments that are on Van Allen, which are out in space. With this, you're getting the ground magnetometers that are observing on the surface of the Earth.
So then they can compare them.
Yeah, and actually, that's a good experiment to do because you can then see. All right, the way to do it is actually to go. You look at the IMF data from ACE. And then you'll see that, when a CME comes past ACE, then you'll see the impact at the radiation belts. And almost immediately after that, you will see it occurring on the surface of the ground. So just quickly going back to the RBSP gateway here. Like I say, this includes these DST index and KP, which is another storm indicating index. So when KP spikes up, that means you've got a storm occurring. And you will normally see there'll be a slight delay before there's an effect in the radiation belts. But you will see a noticeable effect. It's clearer, actually, when you're looking at these context plots. In fact, you can see here, this was a storm from last week. And you can see clearly, see where this peak in KP happens at about the, where is it, a little before the 9th of June, this spike here, and then a little shortly after you get this reddening, this brightening here in the radiation belt particle data. Okay.
Thank you, Rob.
Yes, thank you. That was really exciting. That was, thank you for going above and beyond as well. That is going to be very intriguing for many people in our community.
It's very important for us that we engage with you guys as well, and we get these students looking at real data and playing with this stuff. So it's an important part of our mission as well. So thank you.